didn't get to see on air. So I'm just going to break down the morning schedule a little bit after that. We'll have stress testing FFE1, and then FFE1 and Matroska digitization and contextualization live demo of MediaConch, and some Matroska tools from Steve. So I think that will kick us off. Then we'll go to lunch, and then we have 2 talks in the afternoon, which we'll talk about at that time. And then we'll break, and then we will go into an unconference at 14:40. And then we'll sort of work on maybe grow up what we talked about yesterday and turn those things into maybe more productive takeaways. And then we'll close after that. So that's our day, but right now it's Dave and Jerome and Steve. Hello there.
Everyone, so I mean, you were probably there, a lot of you, and saw what happened. But I mean, like one thing I like about how this symposium is arranged is that like it allows the archivists to see the standardization process rather than just be the reactors to it, and the ones who kind of bear the problems of the faults of the standardization process. These formats have had a kind of a long history of developing in kind of local format-based communities, and now that they're developing in a standards organization, the way we kind of communicate and develop and prioritize is substantially different. I think for Steve and I, it was our first time being present at an IATF meeting. Jerome had experience, so he might have like hummed right away when we didn't know what to do. But yeah, I guess I wanted to give each of us the opportunity, but some statements about it. I find that I don't know how evident this was in the stream, but to be present at that event without good preparation in all the policy is a bit tense. It's kind of unclear how you can behave or what you are allowed to do, but it is very clear that there's an enormous amount of policy and understanding from the IATF participants that kind of hangs out over everyone, and some of it is difficult to understand. I know, like I think in the stream you could see that there was one microphone for speakers from the audience to cue, announce their name, and to speak. And then immediately behind that microphone is another cue and another microphone for people to interrupt the person at the first microphone. So like I'd be speaking and then hear from behind me like somebody else to ask clarifying questions or to give some reaction. One thing I had mentioned at one point is that talking about the workflow, that like there was a deadline of June 8th to hand in RFC drafts, like the very particular formatting of a document that the IATF requires so that it could be reviewed. We had to hand it in about 8th so that then it's kind of closed and fixed in time up until the conference, so that people within the IATF have kind of a fixed, stable document on which to comment up until and while the conference is going on. The producing an RFC document is quite complicated. In our community, there are some from the IATF community involved in the Stellar Working Group, but a lot of us are coming from elsewhere to work together. So the working practices for document formatting are certainly new to us. A lot of us have familiarity with working in Markdown, and so we had to find a method to take Markdown and convert it into an RFC, and this was an enormous challenge. So, but eventually we have a makefile that we can use at any point to convert the documents that we're working on in means that we feel comfortable into an RFC document, so that the IATF community can see it and we can participate in it in a way that is a bit more comfortable than working in an RFC document directly. When I was discussing this, I mentioned that the deadline helped inspire a lot of the work to get these documents ready in time, and kind of caused some rush. And then the area director got up to talk about how He is happy and quite horrified to hear about, you know, the kind of deadline-driven approach. You know, so one of the, I mean, I personally am quite deadline-driven, so I think, you know, kind of one of the compromises here is to make more granular deadlines, because like maybe if we have more smaller deadlines, then the deadline-driven workload is not as impactful, or certainly. Another thing we kind of talked about after, this wasn't part of the stream, I believe, but was about, like Tessa had at one point asked for strategies on like how to get volunteers or advice, and then nobody gave her any advice. So she just kind of sat there silently. Afterwards, Tim was making a suggestion to say that if you want other ITF groups to review your documents, and they are not, you should offer a trade to say, I will review your document if you review my document. You know, this naturally takes more time, but it's worth, you know, is probably a worthwhile fair trade to do that. You know, it's in the ITF, it's an environment where you know, a lot of people there are sponsored, like the workplaces kind of permit them to go, but it's a very much a kind of a volunteer environment. You know, these kinds of tradings I think are a good idea without necessarily putting unfair expectation onto other participants. Before the meeting, Tim Terryberry, the co-chair, had sent a very long email of things that we needed to do with the EBML document. We had thought that the EBML document was pretty close to done, but then got a very comprehensive set of documents, like picking apart every little piece and suggesting what we need to do. I should say, like, this list includes changes that need to be made that are quite simple, and then some that are quite complex. So I think a lot of the feedback we've gotten in preparation of this meeting and during the meeting that we could use to help facilitate anyone who might want to participate in the project, because we have a lot to do and it has like a wide range of complexity. I think often, like, when you look at the mailing list, it gives an impression that the discussions are quite specific and complicated. And you know, like, I'll see threads that Jerome is on about FFP1, and I will understand that if I really want to participate and give feedback, I'm going to have to like invest a lot of time to sort of understand all that's being discussed, so that I can have an opinion on what the current status is. But with a lot of the information we've gotten lately, I think a lot of it is sort of easier cleanup that we need to do. So I'm glad that if the EBML document was adapted as a working group. Thanks for humming remotely if you did. The Matroska document clearly has a long way to go. But one thing I think we should do moving forward is that the EBML is kind of this foundational format that Matroska is based upon, and it's not so well known. The particulars are quite specific. There's not a lot of community knowledge about EBML, but there is a lot of community knowledge about Matroska. So I think in the Cellar Working Group, we should kind of do more promotion to the review, so that we can kind of look, you know, element by element at the metadata dictionaries, at recommendations for usages of chapters and attachments, you know, so that we can get communities like, you know, anime in particular, you know, involved in the process, and like vetting the work as we go. I mean, as we've seen kind of like by the presentation about WebM, like they're like, you know, collaborating, like I'm coming from the preservation context, but collaborating even with the most modern usages of the format, like, you know, have a lot of benefits. We shouldn't, you know, our community shouldn't work on the standards alone, like certainly collaboration is a lot more powerful. Yeah, so that's my feedback on the idea. I don't know, what's going on? Probably Jerome, I bet, he's so eager.
You said almost everything. I don't know exactly what to add. There is some discussion about the video codec, what we should put in the video codec directly, or what we should put in the container. And we remarked some disagreement about which path we should which path we should use. We will try to to make everyone happy in this working group, and we will try to find solutions. There was more unofficial discussion after the official part with the video part, and from my point of view, actually, the most interesting part at EATF, it is after the official part, surprisingly. So when you are remote, actually you don't have everything, and it is pretty important to be on site, actually. I think that's all for everyone, no specific point.
We got to talk about bear formatting, I think, maybe?
Yeah, there is some talk about new features to add to FFP1, XYZ, their color space, and more information about colors. So it is interesting for archivists in order to be able to save everything. But this is the stuff we don't know if we put that in FFP1 directly or in Matroska. There will be a discussion about that later on the stellar mailings.
I think in this room, maybe except for Kieran, I'm probably the one who has the most knowledge about ITF because I come from the network programming. That was my background in programming, a lot of network stuff. So I read a lot of RFCs, a lot of work of ITF stuff, and from other documentation I've been looking at throughout my life. I think that they were the most comprehensive, the more useful, and basically stuff like HTTP and RTP, I don't know if you use that. A lot of the basis of the internet is based on these specifications that they designed. So I had a high opinion on their work. So I was expecting yesterday to be very technical and hard. It was actually not very technical and not very hard, and I was a bit surprised. And because it seems the meeting are more like also to show that you actually very involved and very willing to go through it, rather than just having, because the whole group was creating mostly online, with creating email with a working group with Tessa. And but if nobody joins the group or nobody sends email, nothing happens. So I think it's also important with the deadlines also to have people come and show, yes, we are there, we really want this to happen. And that's also a way to get traction and get more people involved in the process, even from people here. So for me, the ITF is one of the standards bodies that I highly recommend, and so I'm very happy to work through them. It's complicated because their documentation requirements are high standards, and coming from the documentation I wrote, it's a long way. But when Dave is doing most of the work of changing what I did into something better, and I didn't have much time to help him lately, but hopefully I'll have more work to help him during the next months.
Can you talk about the frame rate dilemma that we were talking about yourself?
Yes, there's I also talked about it on Monday as a side joke that the frame rates and basically the time stamps in Matroska are kind of floating points, which for preservation and to have something very precise is not very nice. Floating points, the values are not always precise, and especially if you multiply, which is happening in Matroska. So I already started a while ago to look if there was a way to use rational numbers rather than floating points and change that in the format. I think it might be possible, but we have to look closely. If it's possible, for sure, but that could be backward incompatible, and that's something we want to avoid, even if we create a next version of Matroska. Just for that. So that's something we are going to work on and see if we can improve that.
one of the, one of the assumptions I had kind of about our work, like, I didn't get the reaction I expected. I've worked a lot with metadata standards, and I'm familiar with using XML schemas and XML documents. And Matroska is, designed upon a binary equivalent of XML. So I thought it'd be a good idea to just kind of exploit the benefits of that analogy and have, an EBML schema compared to that works in the same way as an XML schema does, so that you can have a machine-readable document that you can use to do validation and to create documentation. There's a lot of metadata standards that the most authoritative document for the metadata standard is the XML schema, and the XML schema can be used to produce human-readable documentation. And that's the current approach in the EBML draft. That we have an XML that represents the structure and constraints of Matroska, and then we produce documentation from that. And the area director thought that was strange to have like the XML document be normative, like not the human readable part. So I don't know. I'm gonna definitely kind of follow up with some of the other working groups that have kind of faced this dilemma before to get a little bit more experience, on how to proceed with the code.
Well, according to him, it's not very common to have an XML that's normative.
Yeah.
They didn't have a lot of cases on the IT.
Another thing was discussing like should the Matroska specification be broken up. There's like a large part of the documentation that's about the metadata vocabulary and taxonomy, where it's like all the official terms and their definitions. One of the reasons I think we found to break it up is that we could version the taxonomy distinctly from Matroska. Like for instance, if we had more official values to document, particular like preservation or administrative or technical metadata, we could do that specifically in a standard of Matroska's metadata and not in the Matroska standard itself, which I think would help kind of clean it up a bit, so we don't have to version the entire thing to affect one small category of the project. No comments, or we could take questions about this process if you have any.
Could you define what is meant by normative XML?
Oh, yikes, okay. Okay, so in the RFC documents, there's a mandate for a references section so that you're explained what knowledge the document is building upon. And there are two types of references. I think normative means that you have to have a full comprehension of that reference in order to understand the document that you read. So in the case of like Matroska, for instance, for a lot of the aspects of Matroska, you need to understand EBML to understand Matroska. Like if you have the Matroska specification alone, you'd be missing some context. Like you wouldn't be able to like implement it in a player, for instance. I can't remember what the other type of reference is called. It's not normative, but it's something else. And it's they are citations and references to documents that are clarifying and helpful, but not knowledge that is like mandated to be understood before understanding the main document that you're in.
Informational?
Could be. That sounds good. But yeah. Cool. Any other questions about IETF standardization? Formats? Good morning, guys. Okay. Oh yeah, we're on time. Yeah, we're supposed to end right now. Okay. All right, I'm going to introduce the next two talks. I can't remember who was first. Is it Peter or Kieran?
Same slot, so it's...
Oh, all right.
No, I just put it there.
Apparently this is a good
You want to?
question ask.
Yeah.
Should we have an audience vote who goes first? All right, oh, yes. I think maybe Kate talked about this a bit in her presentation, the relationship of test files to a specification and what test files can do. So both Peter and Kieran have worked in using files for testing codecs, and in a way that has created probably hundreds and thousands or potentially millions of files. The results of these two projects are kind of handled in very different ways and had different conclusions, but doing these kind of massive comprehensive tests definitely helps find bugs in the implementations, and also kind of reveals where in the specification you might need to clear things up or make them more specific. So I want to introduce Kieran and Peter to talk about the projects that they were involved in. All right, it's Kieran. That's behind you.
Anyway, okay, I'll have to read off the screen. All the way. There we go. Right. Thanks for having me. It's very nice to come here. It's really nice to meet you. Yeah, so I'm going to be talking about buzzing FFV1. So who am I? Not an archivist. I work on FFmpeg and X264, big sort of mainstays of the open source multimedia world. I've organised a lot of events around using open source in mainly in the broadcast, but I also say /pro world. This is kind of how we consider this, or something like that. In my day job, I started a company called Open Broadcast Systems. We build products for around open source software, a bit like Red Hat for point-to-point live broadcasting, so for news and sports. If you're stupid enough to follow us on Twitter, you may know that it's not the usual corporate Twitter stuff that we post about. It's quite interesting. Yeah. So what I was really talking to talk about is codec and container resilience. So both for us in general, it's really, really important for codecs and containers that have corruption of some sort not to crash, and that's usually from two kinds of cases: bit corruption of some sort. That could be storage-based at work. It could be because of satellite links or some kind of losing, well, bits flipping as a result. Or if it's some kind of packet-based network, we've talked a bit about IETF recently, there could be some kind of packet loss, two different types of loss essentially, chunks of data missing or bits flipped. And lots of decoder implementations are not really written with this in mind. And also, in some more rare cases, encoders can crash on input. Unfortunately, a much wider input space, because you've got all of audio, an arbitrary combination of audio and an arbitrary combination of video, much harder to test, and I'm not going to be able to cover that. Two main reasons for doing this. The big one that the industry uses for fuzzing, as I'll talk about in a minute, and I'll explain what fuzzing is as well in a second, is security. So crafted data can cause untrusted code to be written. Most famous example of this is QuickTime for Windows, full of holes, and as you may know, Apple have basically made it end of life, I think, a few months ago. And that's because their implementations have a lot of issues with not being designed for robustness, and as a result, are very, very easily exploitable. And general resilience is really important. We want our implementations to be resilient, so I want to be able to chuck as much rubbish in as possible, and I still need it to work. Well, I don't want it to crash. It may not produce something useful, but it doesn't mean someone's woken up and has to go and restart something, or a day job. That could be a black screen to 10 million people. No. So what is fuzzing? Fuzzing is feeding some kind of random invalid data to a program to cause it to crash, hang, leak memory, assertions, which are sort of programmer-based checks that people put in their code to find edge cases. Most famous thing that's found with fuzzing is the heartbleed bug. And in the open source world, so two main open source projects to do this, ZZuff and AFL Fuzz. So ZZuff is really a brute force tool. It doesn't really have much intelligence. It just kind of randomizes data in a file, and then you run it through your program and you see if it can crash. AFL is much, much more intelligent. It's able to go and analyze a program, be that open source or closed source, and understand how that program is parsing the file and create test cases that are deliberately designed to extract, to cause crashes or some kind of issue. And fuzzing itself is now becoming a standard part of unit testing when you write software, more and more these days. It should be in anything that handles untrusted data, but where's the VLC? Yeah, but we're getting there. And it should be in anything you do these days that you should you should fuzz it really, because anything that takes untrusted input could have a security issue or some kind of resiliency problem. So FFV1, so at work we have a dedicated cluster designed for fuzzing. Mainly that's used for work stuff, FMPEGs, H.264, MPEG-2, VC2, and we use a framework called UPipe to do something called framing, which is basically taking in a live feed and cutting it up into segments. And so one day on a Friday, the cluster was not used at the weekend. I just said, let's chuck some FFV1 in and see what happens. And then on Monday morning, I opened it up. Oh wow, okay, that's a lot of issues. And ended up over, I think, the course of the week, reporting all these tickets. And they've all been fixed now, which is really good. So you now have a resilient decoder, an even more resilient decoder. So one thing I was kind of thinking I haven't quite talked about is, maybe that's on the next slide. Okay. Oh yes, so time to see some FFP1 doing fuzzed. Let's see if there's going to work. So that's, yeah. Can you read that? We change it to white on black. But anyway, so that was set up, I think, a few days ago on our little sort of test machine. It's not even production fuzzer, so it's an Intel NUC. It's about this big. So you can see there that we've done 73 million different files have been created. So if you look at that, 73 million different FFP1 files have been created. And it's running quite quickly. So one of the problems that I'll talk about in a second is these are just random files I found on the internet. So I think off Peter's website maybe, but you need to find lots of small files. I've only got one, but that one file alone was able to find 5 crashes. So yes, so yeah, I'll talk about it in a sec. So what are the problems of doing this? So there isn't a native FFP1 bitstream format, so it's not like, I believe it's only possible, at least from a FFmpeg point of view, to handle it in a container. So, but the fuzzer isn't aware of this difference. The fuzzer just decides to randomize data, so you can actually reach a stage where, the resiliency of the container could actually hide issues because the fuzzer just changes bytes and data randomly. And your decoder might say, but there's an error in the container, and not bother to decode any more corrupted data. So that's kind of one of the problems. With other codecs, we would usually fuzz without any container, so you would know, well, I'll talk about in a sec, but most of the time you would know that actually what you're expecting is happening. So in the beginning, we used the fmpeg.c program. So that's just the main program. You type fmpeg, and you see lots of thousands and thousands of options. So this is far too complex for fuzzing. It's a very complicated program, and it's very difficult to understand what it's actually doing. One of the things fmpeg does that is the reason things like VLC can play lots of files is something called probing. So instead of actually trusting what's in the file, what the container says it should be, it actually just tries to probe. One of the big pitfalls with fuzzing a multimedia application of any sort with fmpeg is you may just be fuzzing probing. So you may leave it and say, yeah, it's doing a great job. I leave it for a week, but actually when you dig down, all it's doing is all fuzzing probing. So all that's happening is it's saying, oh, is this a 264 file? Is this an AC3 file? Is this whatever? But it's actually not doing any decoding or anything of that sort. So you can actually spend a lot of time. One of my colleagues did this very recently. Thinking, yes, I've run it on a fuzz job and it's completely crash-free. But when you actually look at it, it's not actually doing anything. It's just trying to guess what the file is, but failing, and then starting again. So to solve this to improve this problem, we wrote the ffuzz program. So it's a really simple program that's based off the examples. Talk a bit later. It also has some other advantages that we can. It doesn't need to be respawned. It uses a special property of AFL that within the same process it can be run multiple times. Whereas with fmpeg.c, it's far too complex to reset the state of that. So I've not touched any encoders, I think, apart from audio encoders for fuzzing, because the space of input video is so massive. Audio encoders are possible to fuzz, so you can take a wave file, probably a sine wave or something, distort it, and I've seen audio encoders crash quite regularly. Actually, there was a jingle on some program at HBO Asia at about 8 o'clock every evening, and then it used to crash. It used to do a divide by zero. But I've not really seen anybody do anything with fuzzing video encoders. That's a sort of interesting thing to look at. I'm not entirely sure what to do about that. So all of this isn't systematic at all. This is just kind of, I have some files somewhere that are small enough. I'm going to put them on the fuzzer, run it over a weekend, get on with my life, and then see what happens after that. It's not systematic. There isn't really an understanding of, okay, I've made this change. Now I should run this corpus on 10,000 files, find these issues. Or I've made this change that I think is an improvement, but actually, it's actually broken. Well, my normal test suite that's only there to say, am I still lossless? It's fine, but I may have broken resiliency. But you're not really, it's not at all systematic, and there's not really an understanding of how changes affect the fuzzing process. And that really should be part of the test suite of some sort, but I think because of the time it takes to fuzz large data sets, this hasn't really happened yet. So obviously, what you do when you have a faced with a complex problem, you get an intern to fix it, and this is what we're doing. So getting a summer intern, maybe a very late summer intern in about 2 weeks, and his job will be to try and make this systematic. Again, as I mentioned, this is kind of, so the point of, well, one of the sort of demands of fuzzing is the files need to be small, so 100 kilobytes or so. And we don't really have a good test corpus of FFP1 stuff. We just, certainly when even with the H264 MP2 stuff we do at work, it's just random files that we have, and we just stick them in and see what happens. But we don't really have a big corpus of, here is, I don't know, an HD one, an SD one, testing this feature, testing this feature, testing this. We don't. They're just random files that we happen to find, and so don't really have that as a test corpus. But it would be really nice just to have a standard corpus of data and just say, I'm going to fuzz this stuff, and then every week or something to happen as we make changes. FP1, to be fair, the FP1 decoder doesn't change much. I haven't talked about it, but probably this is something that should be done for Matroska. I think that's much harder because the kind of, almost by definition, the container is a relatively thin layer, so you'd have to be able to sort of figure out how you the fuzzer would only be able to modify the container and not any of the payload data? Or would it even matter? Yeah. So yeah, that's one of the challenges. So hopefully my intern will build a test corpus of lots of little files, lots of little codecs, and we can actually, like we do with normal test routines for taking data, making sure it's lossless, or making sure it's decoded as expected. We should do that for fuzzing. So FFP1 doesn't move much, but for various reasons that I can discuss later, 264 and MPEG-2 change a lot. This is kind of the bane of my life, but never mind. So there's, yes, for extra credit, there is a lot of further reading. Yeah, I maybe should have made some tiny URLs of those actually. But anyway, you can see them later. I'll put these slides up somewhere and you can read them. Don't know if anyone had any questions? Dave's waving.
So, I mean, you demonstrated how in fuzzing, you came up with recommendations and on how the decoder itself should be changed. But I mean, from the testing, do you have any conclusions on how the specification should be changed?
No, these were, I don't know, that's a question. So these issues, let's see if we can click on one. Oh, so let's look at that one, for example. So that was, I don't know what it was. So that was some kind of condition where they didn't expect that branch to happen. So these are all implementation related. I'm not sure. Certainly you're in this. So you're probably in an interesting position because you're actually able to define the specification, whereas most of the fuzzing people do, it's already on things that are there. So I've not really thought about that. That's actually an interesting question. Can you build resiliency into your?
I'll follow up.
That's an interesting question.
Have you tried LLVMs with fuzzer?
No, and I'm not sure which one is better of AFL and the LLVM. There's lots of. I didn't go. Could have gone into way more detail, but there's lots of different things, lots of different combinations of things you can do. And there's address sanitizer, which I have not got to use. I used the LLVM AFL fast mode, but then you could also do a stress sanitizer on that, which is I've never managed to get working, but I believe it's possible.
Yeah, when I was testing with them, I found LLVM's fuzzer to be faster in the instrumentation for ASAN, MSAN, and WSAN.
Okay.
Very useful. So might be,
Yeah. Oh, that's an intern thing to do.
yeah.
That's good to know.
Yeah. Thank you. Of course, I have a lot of questions, but this could take on forever.
So they're just files off your website. There's random files I can find because there's no plan to it. It's just like it's Friday. There's unused compute time.
It's still really interesting. So.
All the computers booting up. Hello, good morning again. You've seen my face several times these 3 days. Hope it's okay. Thanks a lot. In different talks with different people in these days and in recent years, I wanted to ask maybe 3 questions that might seem a bit stupid or strange to you, but who of you is involved in archiving, like not like institutional, where the job is like we are there to preserve stuff? Okay? Who of you can continue their work, their daily work, or other way around? Who of you can actually pack their stuff and go home if the computers don't work? Who of you can actually continue some of the work if the computers don't work? Yeah? That's good. That's good. But it doesn't seem like the majority. Who of you who work in institutions have people that actually are responsible for knowing computer stuff? How big is the overlap of these beings, usually called IT guys, but most people that I know, and you can actually talk with them about your archiving needs. Yeah.
How big is the overlap?
Okay. That was an evil question, like how big is the overlap? Okay, well what I'm trying to get at is that when I ask people like, okay, where's the person I can speak with that is able to exchange on a certain professional level, speaking about things that your work is depending on, I very often get the answer like, okay, we have the IT guys, but they only say that they set up our computers on the network. And then sometimes we catch them that they kind of like do things where like they don't care about resolution, they don't care about aspect ratio, they don't even care about like, oh, but JPEG is way smaller, or why don't you do like lossy H.264? I can do it on my computer back home. What is wrong with you? Why are you doing all this? So who of you has experienced something like this, that your IT guys don't necessarily care or understand the archiving needs? I will raise my hand. Okay. That was just an input from me. I will not tell you what I'm doing with it. But it's actually really tricky to work in that situation. At least I find it tricky, because if I ask like, okay, who can I speak to? And there's like, there is no one, or they're not responsible, or they don't feel responsible. That's something I think that should be changed. Okay, I'd like to have a few more minutes. I will not waste too much of your time. What we've seen so far is Kieran was fuzzing files. He was actually testing how well does the stuff behave when you come with broken input. What I did, it was not randomly. What I did was taking a set of test files, different test files that I could get that are publicly available as reference files, to put it in with different properties and parameters for FFV1 encoding while the development of version 2 and version 3 was going on, because Michael MediaArea said he needs feedback on how stuff behaves. Now, the collection for input videos that are available for everybody else to reproduce test results, it was very important for me, because otherwise I could just put in videos, claim anything, and nobody could actually reproduce my results. It would be good for me if I want to hide stuff, but actually I wanted to be able to reproduce the results. Now what I found out was, it's not that easy to actually get real variety of different formats with different properties to actually test stuff like from 8-bit per component to 16-bit per component in binary color space and RGB and subsampling and so on and so on. Of course, I can generate these files, but they behave slightly differently in terms of compression and other stuff when they are synthetically generated. I found out there's not a lot of stuff that you actually get under a license that you can reuse. Now, I think it's kind of live. There's this, that's the extra, it's just a forum that a friend of mine and I have set up, and he and we post a lot in there. And so there's like this guy called Rooker, and then there's this Peter B guy. And I put together some links about test videos. So there's the DERS collection, and so on and so on. And then I was looking for like professional stuff with 10-bit or film source or something. And I found some from the Swedish television that was really good. There is a note about the European Broadcasting Union files. I don't know if they changed it yet, but they are actually not freely available for anyone else to reproduce, just for EBU members, or for quite a costly amount of money. So I was not too happy with this. So what I stuck to at the beginning, what I stuck with at the beginning was this dirt collection. So you see, there's a lot of videos with quite old content and really weird people on there. No, they're not weird, it's just like the 80s and the hairstyle and everything. So some videos, and they were used for MPEG and lossy encoding tests for, I don't know, 20 plus years. And now down there, there are some videos which are actually HD and beyond. You have now, they weren't there when I used them, like computer generated graphics and other stuff. So you see, it's quite a list of videos. What I did was, I sorted them by resolution of the original video. These letters are the definition of resolution in a certain speak. It's like quarter CIF, CIF, and this is like a certain resolution that was used for sub-standard definition resolution for real-time transmission or encoding in times where video on a computer was really a hard task. So some of these videos here, the early ones, you see they have like 44 megabytes, and we're speaking about uncompressed 44 megabytes. The resolution is cute, considering nowadays resolutions. So, let's take a look at what I did. What I did was, I wrote a program that calls FFmpeg, goes through these videos in a folder, and then produces different outcomes, like uses different parameters for encoding it in FFV1, because for version 1, you only had 4 variations. You had 2 parameters, coda and context. Both could be either 0 or 1, so you have 4 possible permutations. That's nice. With version 3, you had slice COC yes and no, which is doubles it. It's just 8-bit. And now you have slice numbers from 4 to 30 something. Long story short, I had like 1 input file, 200 something output files. And I did this number crunching on my computer at home, similar to what Kieran said. He said, yeah, the computer was standing there and had computing power over, so he just left it running over the weekend. I did this for weeks and months, and every time I stumbled over something, I had to reset it and run the tests again. So this was running for weeks and weeks and weeks and weeks and days and days and days, and now I ended up with a lot of numbers. So for this list of videos, multiplied by 260, and I only narrowed down the permutation combinations because they would have been way more if I had a complete set. Because I had to do YUV, some RGB, some subsampling variations. So here you see, is it big enough? I hope it's readable. Yeah, something like okay. Here's the file names, and that's just standard definition. You see the 640, 480, and here's some PAL resolution as well, and some is NTSC. Now, no, you miss out on all the colors. Here is actually a slight green. Maybe I find some with a better green, because you don't really see it that well here. Oh, that's really red. I'm gonna have better green. No, you don't see the green. Yeah, green. Okay. Now, this table is really, really confusing, but I didn't come up with a better way of putting all these numbers in some readable form. So you have FFP1 version 1, 4 variations, like coda 0, context 0, coda 0, context 1, coda 1, context 0, coda 1, context 1. That's like all these weird numbers. Then you have version 3. Then you've got 4 slices with permutations of coder and slice CRC on and pass 1 and pass 2, 30 slices. You don't have to remember this. It's just like so that you see, I only picked out a small subset of parameter variations. What I was getting at is there a difference between a GOP size of 1? Like each frame decodes by itself, Or if I do an interframe, because FFV1 can also do this, but we don't want to do it for archiving, if I have a cut of 300 pictures, is there any compression difference? And the greener it is, the bigger the difference. So this is like really green, so using one frame as like only encode every frame or 300 depending on each other is 31% difference, for example. Now, the size difference here. That might be more interesting for you. This is how well it compresses compared to uncompressed. So what I did was I calculated the uncompressed size of the input video, then I compressed it, and then I did a simple subtraction and say, okay, how well is the compression here, for example? It compresses up to 30%, which means it's only a third that is left. The rest is like half, half, half. Most of it is like half. And I found something very interesting. It should be in HD and beyond. 90%. I was like, what the hell is this? It compresses down at only 10%, like even at the 10th of the size. I'm like, there's gotta be something wrong. Actually, you see a lot of over 70%, 80%, something. This is for computer-generated content. Like, Sintel is an open movie that was rendered with open source program Blender. So it's a computer-generated movie. And all these computer-generated movies are so clean because of the lack of noise that they compress, they have to be like a 10th of the original source. It was really like, hey, yay, so if we would be working with computer-generated movies, that would be awesome. But they probably will only make that a fraction. Or in the future, when they get rid of all these movie stars because of their attitudes and their costs, maybe we will have more archiving content that compresses down to 10%. So, if somebody asks you, but has anyone tested FFV1 with different resolutions and different input files? I said, as you see, this is just HD and beyond, and the others are split here. So you get a few hundred here, a few hundred, some here, some here, some here, and then I had even a MediaTek collection where we took 3 files and even put 2 of them, no, all 3 of them actually. I put them on a server so people could reproduce these because I wanted to have files with material that we actually had from the archive, like from a digibeta or from VHS, because I couldn't find anything of this online. So I only took 2 publicly because of the rights issues. I ran other tests, but I could not publish them because you'd not be allowed to have these files. But at the MediaTek, there are enough files that we could do testing with. So far, so good. That was a short look into the work done in order to be able to say, yes, FFV 1.3 can be released, and we're pretty serious that it can encode and decode properly. Oh yeah, by the way, with all these files, I used Frame 5 to validate that what goes in losslessly comes out. So every single file you see here, it was not only tested for performance, but also that the encoder really is bit exact lossless. Any questions or comments so far? Yes.
This GLP feature generally is not recommended for archiving.
Mm-hmm.
So why did you use so much time on it?
Because Niedermeyer requested it, because he wanted to know certain behaviors of the codec, where I can only say that I don't know too much about the algorithms and internals used, but he said, please give me numbers for how the behavior is between these GOT1 and 300. But a nice side effect from this is that here is something with P1 and P2. It means first pass and second pass. So there is the possibility to encode a file and have the encoder take notes while looking at the file, and then encode it again using these notes so it knows what to expect. And then it can actually compress it better. It takes twice the time to do this, but and it's really difficult to read. If we have, I showed before, here we have 30% gain in GOP size 1 or GOP size 300. Like 30%, that's pretty nice. That's a really bad example. Okay, if we do a 2-pass mode, we gain almost the same compression as using a GOP size of 300 with a GOP size of 1. That means that there is even greater potential for more compression if using multipass mode. It's not working properly at the moment, but we've seen in these tests that this might be something to go for if somebody wants to do their collection and they have enough time to do a multipass encoding. It might even be possible that the encoder takes note during the capture, if the capture application supports it. And that was we had to do tests and find out how this stuff actually behaves in order to know stuff. Does that answer the question? Anything else?
What do you mean it does not work well, the 2-pass?
The 2-pass?
Yeah.
It crashes if the file, the pass log file is written as text with numbers, and it gets so incredibly huge for very short files, and I'm speaking about seriously short files. If you try to 2-pass a 10-minute file, it doesn't work. It worked with these short clips because there were only a few frames because they were uncompressed as source, and so here it worked properly. But when you do it with a file that is a few minutes long, the pass log file becomes several hundred megabytes of text to be parsed, and that crashes the FFmpeg encoder.
So it's not ready for production with
Exactly.
1-hour videos for the moment.
Exactly.
Proof of concept.
So this was like, okay, that's something it can be worked on if necessary or required, but we got a lookout on what to expect in terms of compression gain. I see. Anyone else? Well then, thank you, and we shall continue with other things.